Hello, everybody. People are still walking in, so I will try to get started slowly. It's good to see you all here. It's definitely, I think, one of the best developer events to attend, NDC Oslo. I'm happy to be here, standing on this stage. And in the next 60 minutes, a little bit less, hopefully, I will talk you through, and we're going to look into how we are using GenAI inside our code and in our code, and then wonder what could possibly go wrong, right? And there's a lot. I was really happy to see the keynote yesterday done by Leila on the same direction. I've got certain things you will see a report that might look familiar because we all look at the same reports, right? But I'm definitely going to put more of my security hat on. And it's good to introduce myself for the people who don't know me. My name is Niels Tanis, and I work as a security researcher for Vercode. I have a background in .NET development, and I started out my development career with the first bits of .NET, so that's a while ago. And I always kept an eye on security, software security, and then in 2015, fully moved into the AppSec field, and in 2016 I joined Vercode, where I'm mostly focused on static analysis of .NET, which means looking into code bases, software, and finding security problems, and that we can help out our customers doing the right thing. I just wrapped up my view of Semantic Kernel. We're going to see some Semantic Kernel in here as well. It's not a deep dive. That's probably a different session, but it's more like we're able to integrate all of this goodness to a certain degree. And I think we should definitely be more aware what we're doing. So that will be the stretch. And if we look at generative AI, the first thing I did, I went to Bing Image Creator. Probably everybody knows it. So I'm in my slides, there's a notes version I will share at the end. You will find all the links to all the articles that I'm pointing out to, so don't worry about any of the sources. They're all there. You can even find the link to this image. So I asked Bing Image Creator to create a LLM generator that generates source code, and this is what you get, right? And it's like, okay, looks kind of funny. The first one might be a machine. The second one, you definitely see some glitches. And the third one is like, hey, that's almost like a steampunk kind of thing. That's something that's generated. You see that it's not real, right? That's the thing with generative AI. How do we look at those things? And with pictures is obvious, right? But once we're going to do stuff with code, what will it end up in then? I think might have been a month or so ago, you were able to generate a Muppet version of your own picture. And that's what I did. You should have seen my daughter, 13-year-old, laughing at me like, Dad, that's stupid. I said, yeah, but I like this. This is fun. Especially if you look at the detail of my jacket that I'm wearing and the shirt, and then seeing the perspective being reflected in that Muppet. I do have a bit more hair than this one because there's still one on the top, but it changed a bit, right? But I think this is funny. This is cool stuff. And we can generate things. And if I then put my security hat on, I would like to know, what are the risks? What are we working with? If you go to learn.microsoft.com, you have AI security fundamentals that have been written by the advocates of Microsoft. And they define 3 fields of layers where you can look into if you look into AI and security. And one of them is the usage layer. So let's say a prompt tool or Claude or ChatGPT that we run on our system, that we then do prompting towards an LLM that gives us an answer, right? That's the first layer that we can look into. The second layer would be integrating an LLM into your application, right? Semantic Kernel, good example. All the other SDKs you can get with all the other stuff, it's quite similar, but integrating it into your software, what could possibly go wrong? That's the area you need to look into. And then the lower part will be the platform layer, the fact that we rely on LLMs that get created, that are running somewhere on AA Foundry or on AWS Bedrock for that matter, are all types of risk layers. So I've chopped off this agenda into the following sections. I first briefly want to touch LLMs to have a full story. We're not going to go into much detail, but there are some cool animations and just a brief introduction to have the full narrative for you. Then we're going to use some GenAI and look into how LLMs generate source code. That's mostly, so there's some real cool academia that explained and that looked into those things over time. We will see papers that start out in 2021 and ones that are from last year, and then we can see and jump into conclusions. Then we're going to look into how we can integrate an LLM into our application with the help of Semantic Kernel. And one of the demos, and there is a bit of an Easter egg, and we're going to walk through and see what we can do with that. Then the last bit will be more about if we're going to build an LLM system, build LLMs, have it run. We need to have training data, right? It needs to come somewhere, from somewhere, or we rely on a vendor to do it for us. what are the problems that we need to be aware of? And then at the end, what's next in conclusion and QA. So if you look up what LLMs are, then there's one paper, and I'm not saying it's the first, but it's probably one of the first that was introduced, which is attention is all you need. And the diagram on the right-hand side shows us a autoregressive transformer. If you want to say it out quickly, it's a pretty bad word. But it's just a next thing prediction, right? It's next token prediction, and it does it based on the data, the corpus it has been trained on, right? Nothing new in that. And based on the data it has seen, stuff will occur more and will occur less. So that will have its effects on what the LLM would provide as its output, right? So that's the thing. And if you then go into YouTube, you can find a site called 3 Blue, 1 Brown, which have got like a lot of cool videos on how it works, but I also have some good visualizations. I'm a guy that needs to see stuff and see how it works. Those videos are pretty good, right? So Paris is a city in, and then France is the most likely, so that's the top one. But they will explain to you how it works. There's also a real good course on Coursera on generative AI. I would encourage you to watch that one. And one of the founders of OpenAI also has a real nice video, and that link is in the slides as well, where he talks about how that system evolved and how it builds and how it works, even like from the start. So that's pretty cool if you're interested in seeing that. And then, as I said, also you can maybe have a prompt. I'm in the city. I want to know what to do. These are the things that it will generate. There's nothing new, right? This is something you've seen all the time. But then, if we look at deterministic behavior, an LLM by default is non-deterministic, which means that it will probably, you should assume, it will give you different output each time you run it, right? Everybody has heard of how many R's there are in strawberry. If you would even ask a simple math question to an LLM, it's probably failing because it lacks doing that. They're good at doing it right now because they will generate a piece of Python code that will do that for you and execute and then give you the results back, right? So they will take the non-deterministic approach, but then there is that piece of code that will execute and give the same answer each time. So that will help out. But I think that's one of the biggest problems if you look at taking that non-deterministic behavior and putting it into a system, and that will have consequences, right? That will have its effect on how the system would behave. And I'm not going to do the raise of hands, but I think everybody probably has touched one of the IDEs right now with Copilot or maybe Windsurf. I'm running a lot Cursor lately. It's pretty good. It helps you code stuff, right? And I think it helps me to guide me. It helps me to look into stuff, and I think that's pretty cool. It makes me more productive and focus on the things that matter most. And we're going to look into more of the quality code later on. One thing I've also done a lot recently is that, I'm not sure if you're aware of this site, but this is called gitmcp.io. And the cool thing about this is it will create an MCP server out of a Git repo and the data that's inside. And I'm doing a lot of security research, and right now I'm doing a lot of Rust research as well. So I'm looking into crates, which are tied to a source repo on GitHub. And I've written a master prompt for myself to say, hey, I'm a security researcher. I'm looking into a source code base. I'm involved in static analysis. I would love to know what the control flow is of this library, how you use it, how you integrate it. What are the data flows? Is there any risky stuff happening in relation to, let's say, if it's a database thing, a SQL injection, of course. If you're more web-focused, cross-site scripting or cross-site request forwarding might be an issue. But this is quite powerful. I tie this one to Claude and run some stuff, and I will have blueprints for my research. And that's productive, right? And that will be good because it will look at the source code based on the repo. I've heard that some of the stuff might be not available anymore. This one is still working. Hopefully, if not a lot of more people jump on it, that they say it's done. But it's powerful, and you can even in Cursor, you can pull in a code base and index it. You can achieve the same. But I think this is rather cool. No effort taken, creating an MCP server by just changing the URL, getting the config in your system, and using it and asking it the right questions. For example, how does .NET Watch work inside the SDK? And you get a whole explanation. That's cool. Moving back to AI and code generation, there's one person, and I'm afraid he's not around this conference, but you probably have seen him speak here, Glenn. And Glenn had this message on Blue Sky in December of last year. And he says, hey, using an AI system feels like you're running together with a senior drunk dev that helps you out. And it might be good. It might give you advice that's outdated. And it might be wrong sometime. And it's like, oh yeah, sorry about that. I could have known that, that kind of thing. I think this nicely captures what we need to be aware of if we use AI to generate code and to look into the details. Now I'm going to move a bit back to the fact that I work for Verico, because once a year we publish a report, and that's called the State of Software Security, where we look into the industry and how good are companies doing in a software security perspective. And in 2014 or 2024, so that's not this year's version, but the year before, we looked into security depth, and we looked into the fact that if you create a piece of software and you start out doing security programs and you want to keep it secure, then at some point stuff doesn't get fixed and you will accumulate all those problems, and that will become security debt in the same way you might have got technical debt if you don't update your libraries for maybe functional reasons for that matter, right? So that's the thing. And in that report, you probably see the design of it a bit. There was one diagram which shows you a certain trend. So if most of our customers start out their program and they have an application that needs to run into production, you will see the new flaws introduced per age, right? So if you go to the right side, and that's for you for that side, you will see that it will increase over time. The first thing that's like a honeymoon phase where stuff gets deployed and everybody's hardly working, and the images or the flaws will drop because the risk needs to be fixed, right? That's what happens at the beginning. But then at the end, we always see the security debt going up. Sometimes system is just running, other priorities, moving on to different things, right? That's just a trend. And if we look into more of the statistics, we can see that almost 71% in 2024 had security debt in their applications, right? So that's like, I think we're close to 450,000 applications, unique applications that we have scanned for this data set. The metrics are all in the report. You can find that one in the links. And 45% have critical security debt, which means even the riskier ones of it. And the newer figures of this year, because I've worked on this report of this year, but I haven't incorporated it into these slides, it's 74 and 49, so it's almost similar, right? So let's assume those figures are in the same direction and in the same heights. If we now look at the fact that the flaws are increasing, I need to draw it like this, you're looking the other way, you will also notice, or we have noticed, that 2 out of 10 teams are able to keep up with the amount of technical debt that they have in order to have enough velocity to take down those vulnerabilities and to have them fixed. The other 8 have still problem. They cannot keep up with it, right? So more flaws will occur over time. That's the thing. And if we then take another sidestep and say, well, software security is hard, there's always knowledge gaps. Even for me, if I look into a new technology stack, I always get excited. If you look at, for example, MCP, the authorization spec of that was produced, I think, a couple of weeks or so ago. Everybody's already using it. It's in Windows, as we have seen in build. So I sincerely hope that we've got it all sorted out in such a way that everybody can use it securely, right? But there's always that gap, and there's always the new stuff that happens. The same counts for increasing of complexity of apps. In the early 2000s, it was the single monolith that you developed. Right now, you're doing cloud native that literally gets deployed all over the place. And that makes it hard to understand. It will also give you an incomplete view of your risk. Like what's running where, and where am I running into risk right now? It's hard, right? You need to have some kind of an overview in order to do that. And then, of course, new stuff is found over time. That's the thing. And let's add an LLM that generates code to all of it that I just talked about, because that's what comes after this, right? So even teams without using AI already have a hard job. What about if we have more LLMs added to that equation? And now we run into the fact like, hey, let's generate code, let's look into some research. And this is the one that was published in 2021, and it is related to GitHub Copilot. I think I saw this one as well as one of the security conferences held in August of that year. Maybe a bit before. It turned out they had like almost 1,700 apps, a little bit less, that were generated by Copilot, and 41% of them contained security problems, which is the average of every normal developer. I think that's the take on it. And the conclusion of this paper is as well, like, although you use a tool, you still need to be aware of the output it generates. You still need to be looking into, okay, I have this code generated. Does it really do? Is it functional? Okay. What about that? I want to do this. It's the same as you saw, like there's like that GitHub agent that can do work in the background. They showed it a build. It's like, and it runs from an issue that's pushed, right? So to some degree, it's like an async prompt that runs somewhere. But the quality all lies in that issue, how well it's defined and how well your code base is defined, because that's the thing it's going to use to fix it, right? But you should always be aware of what you're producing, what you're putting in somewhere in order to be aware of the risk. And that's the conclusion of this, like, yeah, you can use it productivity-wise. It's cool, I totally get that, I'm the same, I'm lazy. I don't want to do stuff on my own, but we need to have the right tooling to keep an eye on the security output of that. Then the next paper is a bit newer, which comes from December of last year, then it was updated. And what they did over here, this is also another approach, but they had like more different apps, more like 400, and once again 36, so that's 40, 36, right? Pretty close. Is vulnerable. They did use a little different, like a set of different languages, right? Because that's also something we need to keep an eye on. But the cool thing about this is that once Copilot generated a thing, if you then gave it another prompt to say, hey, you've got this issue, you need to fix it, 55% of the time can also fix it, right? And that already confirms, like, if you're not getting the stuff out of your Copilot or your coding assistant or whatsoever, you need to ask better questions or give it more context. That's exactly what they show here. I think it's cool that then eventually if you take the tool again and fix it, then 55% of it got fixed, right? It's pretty cool. And then we have the other thing, like the human bias, and Leila also mentioned that yesterday. Like, people get confident, like, hey, I'm generating code, this is cool. Just gonna use it, right? Was not planning to use vibe code, but that's what it is, right? Just go with the flow and see how it goes. This is a study that was done on a group of people, and some of them were like developers that just started out. Some of them had some experience. They got assignments on creating something secure and insecure. And it turned out that the people with less experience, of course, I'm not saying that that's an assumption, that's really bad, I'm sorry. But they were like producing more problems eventually because they relied more on the code. And they said like, oh, the code looks good to me, but if you then look into it with more detail, there was an issue, right? So that's like the bias of, yeah, I'm using this tool, yeah, it looks good, and then eventually there must be something inside, or you need to check it more thoroughly, because at the end it's part of your code base, and you need to integrate it, right? So this focus more on, we talked about more like generating code and using LLMs and what's inside. What about the quality of each of the different LLMs, and how good are they at secure coding, right? And this is a research that was done, I think maybe 2023. My screen is a bit too, no, this one is from 2024, the last paper, and then it was published. So what they did is they created a set of generic prompts and created some kind of a benchmark that you could then throw against all the different LLMs, and I think almost everyone was in this list. And they just looked into, okay, how good is it in generating functional code? Step one, needs to function, right? In case of .NET, it needs to compile, it needs to do something at least, because if it's compiled, it's probably okay. And then, how secure was it? And that was the second check that they did. And in this case, StarCoder turned out to be the best one in that latest data set. GPT-4 came second. But if they then combine it, then GPT-4 created the most functional and most secure code, right? You can create something that's non-functional and secure, but it's useless. So, but this is also a nice paper. I hope they do an update on this. We've got some research lined up to talk about this as well, so keep an eye out on that. I'm interested in knowing how good it behaves, like in different languages, and there is some takes on that. So when I first gave this talk, this was January, and I thought like, okay, but now how do we know that developers are using AI in their source, like in their work day, right? In their way of working, how they deal with source code. And then in February, this paper was published, and that's the one that Leila also mentioned yesterday from GitClear, right? They looked into a time window, I believe it's 5 years, right? Where they said, okay, how good is the code quality? And the latest version, they figured out that there's a surge in code duplication, which means that people are creating the same code bases or like same snippets of code and they get produced. There's no refactoring done. That's a big signal, right? Because if you create a prompt, hey, I need to do this newly, like are you eventually not consolidating stuff into the same thing? Depends, right, what you're doing, but that's the thing. The other thing is that increasing code churn, which means large set of changes were also pushed into the Gits based on their statistics. And there are also declining code factoring, which, refactoring. So less quality, more code. Oof, what could possibly go wrong? If we then look into security in general, we could assume that with the help of LLMs, our code velocity would go up because we produce more code. It fuels our productivity. I'm happy with that as well, right? You want to use it effectively. And the fact that we less focus on reusing our code, that's a problem. If we then assume that the vulnerability density is similar, right, we can only conclude that the security problems that we create are also increasing, right? So worrisome. That's just the trend. If we take it all into account, the first statistics I showed, and then the fact that LLMs help us out producing more code, that's an issue. So what can we do? At the end, it's just code. So, as I said, if you do stuff with prompts or with some tooling, and the output is not the way you want it, or you don't have the desired thing, or there's some problems in it, you should give it better instructions or show the model or the prompt like, this is how we want to have it fixed. Because that will allow you to improve. Models definitely are improving over time. That's the other thing. Looking at it from a security perspective, security still needs to be part of your software development lifecycle. It's not a thing you can do at the end. You still need to do all the testing, the security, and the static analysis, the dynamic analysis, whatever the pen testing may be, depending on the product that you're using. It's all needs to be there. And what about education and training, right? Allowing everybody to be aware of it. So, looking at it from a perspective like, okay, we need to do it. It's just code. It's just going to be there. Is there something else that we can include to help us out? What about if we use LLMs to help us out, right? Definitely the tooling. If the tooling improves and produces better codes, we can do things. And these are all types of security code fixes. And the first, that's us, but every competitor has one as well. They will do the same. Ours is trained by the team that I'm working in with code snippets. So it will hopefully do the right thing for each of the vulnerabilities that you found. But we need to embrace the power of those tools to do a good job, right? And as I said, there's a lot more happening as well with all the others, and it's good that it's around. And even if you go right now, if you open up maybe ChatGPT or Claude and you ask it to generate a website and you describe it, it uses Entity Framework Core or it uses SQL like directly, and it will probably generate parameterized queries, right? Because that's what you want. 9 out of 10 times it still does a good thing, but it all depends on how you formulate and how you ask the questions in order to do a good job. So, a bit more than 20 minutes in, this is the stuff we're going to talk about code. Let's now focus on, hey, what happens if we're going to include LLMs into our application? Like, what could possibly go wrong in that perspective? So, last year's build, there was a talk done by Marcus Zinovich and Scott Hanselman on AI security, and I would encourage everybody to watch it because A, it's funny to see those two talking, and B, it's just a really good session, and I stole one of these slides. I believe they're doing their session today as well, so I'm definitely looking forward to watching that one after this event is done. But we could probably look at, hey, if we look at the LLM application architecture, we see that we have a generative AI app, which might be a client you talk to or something that we have developed. On the bottom side, we see that there are different data sources. We can query the web. We might have applications, agents, or functions that we can call and use inside our LLM, and that's the thing we're going to focus on in a bit. And then, of course, we see on the right-hand side, we have the data sets and the data that is used to train the LLM to give us the output. And if we then look into what are the possible spots where we need to be concerned about anything like prompt injection, it's literally every arrow that goes to the generative part of our application, right? Every spot over there can be affected by data that's has got a different intent and needs to be treated as such, right? It's just a zero trust approach. That's what they say. If you hear Marcus Zinovich talk about it, he says like, hey, it's almost like you have the old Windows machine and everybody connected it to internet without a firewall. That's a bad idea. You need to do more in order to be safeguarded from these kinds of problems. So as I said, there are different ways. We're going to look into prompt injection in a bit, but these are the areas where stuff goes wrong. Who here is aware of XKCD, of those nice drawings? I think a lot of people are. Everybody knows, I think it's Bobby drop tables, right? Everybody knows that one, SQL injection. Bobby has got a little brother, and somebody created this, and I was laughing out loud. It's called Billy Ignore Instructions. That's Bobby's little brother. The same drawing, the same stretch. I like this one when I saw the sources over there, right? if you grab input somewhere inside the way that you use it inside an LLM and it gets thrown against some prompt at some point and somebody can perform additional actions, then this is what you get, right? Getting back to the things. Normally a prompt, if you interact with, let's say, Claude or ChatGPT, you always have a session open and you will have multiple runs where you say, okay, do this research for me, reason about it, ask me questions, like at the end, 5 questions, let me answer them, and then we can continue. You have multiple steps in where you're going to go through and work with the LLM to get the answer you want. So that will include user data. There might be data that's been pulled in by other agents or other sources, maybe reg, like whatever, right? It will be pulled in. And at the end, you will have the answer. And if we then look at a security way of doing it, each of these elements of data, as we saw in the first drawing, will have that red dot, will be the possible way of something getting prompt injection. You've got indirect prompt injection that's done by a backend server. So let's say the example we will see in a bit, but let's say I'm processing email and the email has additional stuff inside of it that's not being safeguarded properly. That might be the thing. And the other thing is the prompt injection we can do ourselves if we type stuff. If there is like a direct input field that ends up in the prompt template, then we can do funky stuff ourselves. How much goes wrong? I can assure you a lot. So this is, Microsoft runs a conference called Blue Hat each October. They've done Blue Hat India a couple of weeks ago, but this one was held October last year. And there was a person, I think he was from Germany, and he just makes a living out of breaking every LLM system that's around in order to improve it. And he does it based on bug bounty, so he probably makes good money out of it. But he shows the different ways on how we leverage AI systems, LLMs, in all different platforms. And he's got a real good blog post embracing the red. This is a screenshot of this morning, where he just explains, like, hey, if you using memory with ChatGPT, there is a persistent store you can put stuff in, and there might be ways of doing funky stuff with that. So this is one if you want to watch. We're going to see a bit more Blue Hat talks once we move on. So let's say we're interested in doing the following thing. We have an LLM service, and we ask it to do a summarization of our emails and send it out, or like generate summaries. That's the take. What if we then instruct the LLM to say, hey, we want to have the summarization of the emails, but we want to have to send this out to this domain. You see on the right-hand side, like first, of course, the emails will be processed, and then the indirect prompt injection will happen because the email body contains something that's not supposed to be there. The white text, I think that's the demo that they showed. You don't see it, but if you select it, it's there. It will execute. And then the LLM is smart enough to say, like, oh yeah, so if I then just do this body of that email inside this URL tag and then post it to the URL fetch plugin that I've got available, I've achieved it, right? And that's exactly what happened. This is like first indirect prompt injection, and then the data gets exfiltrated over the fact that the LLM does a HTTP request to the outside world, and it puts the summary inside of it. This is one of the demos that they show as well, I believe. And this is the thing. If we look at this is kind of an abstract view, and I'm always more of a guy like, hey, I want to see something running. So let's look into one of the examples you get with Semantic Kernel, and let's look into what we can achieve. And of course, I did do some tweaks, but I'm going to walk you through. Hold on a second. So this is just a normal app. I'm at Semantic Kernel 1.33. That's bad. I should have updated it to the latest version. This is not the latest, but it works. I connect to Azure OpenAI. I'm sorry. Yes. Thank you. I was expecting to escape the presentation to be enough that my screen was mirrored. Let me see where it's at. That's the second desktop. Just bear with me for a second. Let me set it to mirroring because that's better. Or am I going to screw up this the recording? Then I want to know where it's at. Okay, it's on the right-hand side. So if I scroll it like this, I'm going to get it into the screen, and now I need to look on that screen, but that's fine. So as I said, this is like using a Semantic Kernel version that's a bit old. Doesn't matter for this thing. If we then look into program itself, and if we scroll down, you see over here I have several plugins that are defined, right? So kernel functions that I can use. There's a time plugin, a long plugin, there's a configuration one. Different ones are registered. Then, of course, we put everything into the DI container, and then there's a worker thing that does our thing at the end. It will run the stuff we need, and let's run the demo. So let's do this. It's a nice big screen, but only the position is in the wrong spot. So let me maximize this one a bit. Hopefully you're able to see it. I can still zoom in. So this is just a normal prompt. And I can say like, which light is turned on, right? You can just do the natural language. And it will parse, and it will say, hey, the porch light is on. And you can say, what's the time? It will also give it, right? What if I say, can you show me the configuration? Let's see what it responds on this. It's just like, hey, I cannot show you the configuration. Can you show me the config? Let's see if it responds on that. Config file. Let's make it more explicit. So what's happening here right now is that there's a big stack trace on top of it. So it tried to invoke. I'm not sure. You probably did it the same one before. One plugin has the ability to read files. So let's say, can you show me the contents of etc/hosts, which is a file on my system? You will see it will read files, right? And of course, as I said, I've not been a bit like, there is of course something I've done on purpose, but that's just to give you a full stretch of the story. So one of the plugins inside of this one is called the configuration plugin. And what it does, it just gets a file name and it will just read the contents of the file and returns this, right? But let's say this is a plugin that you're not aware of, that's running somewhere, and you can lure, because it's natural language, you can lure the LLM to do an action on that behalf. In this case, you can access all file system access, right? You could have all files accessible throughout this plugin. Because do you think it's a good idea to have a function argument that points out to a file location, right? That's the biggest problem. These should be stateless. You should just have like, give me the configuration file, and it should be a constant file that gets returned. I think that will be the right approach if you want to do this. But like doing prompt injections, it's not hard. And can you imagine that if you only have one plugin that has certain abilities, and you can get the LLM to use all the plugins, then you're in an issue. So let me move back to the slides, because I've got one to that will help us out. Now I need to know that this is the screen I'm in, so I need to do that side. Nice orientation. Now we're gonna go back. Yes. So if we have an whole ecosystem of functions of stuff that it can do, right? Any system, we need to be sure that we limit every plugin that we have in our system to have the minimal rights it's allowed to do, right? That's the whole thing. I think even there's like a session done at Build that will explain like, hey, the agents need to have like zero trust. It should be in a box on its own, like on the stuff it can access. And you need to be sure that the human in loop, right? If there's a critical decision made, that the human loop might need to confirm. I think it's almost the same if you start using even like Claude, the interface, it will say, hey, I want to execute this function. Is that okay, right? It will ask you to do it, right? That should be the thing. But looking at, let's say, if you have a system that has a plugin that will summarize emails, do you want to push down all the dialogues you get thrown at you? That's not workable, right? That's not what you want to achieve. So that's still a bit of a balance act. And I think it's just a matter of, aside from all the other points, like you need to have undo capabilities like logging and tracing, know what happened when, right? That's also important, especially in security incidents, isolate every user, and just assume that the meta prompt or the prompting stuff that's done inside that app is leaked at some point or can be influenced. That's the key thing. That's the key thing to take away. I think the real thing is that also at Blue Hat, there was a red team, AI red team from Microsoft who has, like they've done a lot of reviews and they created a report where they looked into 100 GenAI apps, so there are apps that are using LLMs internally, and looked into the stuff that they found in that. And most of the problems lay in the fact that if you have the ability to perform a request inside one of the plugins to an external source, something that we would call a server-side request forgery in security context. You have the ability to do that, sending out that email I showed before, right? Getting data out or getting other data in by exfiltrating that. And that's still one of the biggest problems, server-side request forgeries, especially in this kind of apps. There also is a video of the same team explaining what they run into even more, but it's good to see that it's something that's actively done. And they also produced a really nice framework called Pirate. I believe the name was generated by an LLM as well, Pirate, right? And it's just a tool that will help you automating, throwing stuff against LLMs. You can probably imagine the prompt injections we saw before, text it didn't accept, but then if you create ASCII art of it, it was able to understand it, right? The language changes, maybe different encodings. There are so many ways on how you can get data to an LLM or to a process that deals with LLM eventually that you want to test. And I think Pirate is definitely a nice tool to look into and actively developed. And the other thing is that, as I said, LLMs will improve over time as well. OpenAI published something called deliberative alignment in December. And then a bit later, I think the day after, a couple of days after, Marcus Zinovich says about, yeah, so it's nice that they created it, but it's still vulnerable to crescendo attacks, right? Because I'm not sure if you're familiar what crescendo is. Crescendo is almost like social engineering an LLM, where you're just going to slide its context of talking about one thing and it's not allowed, and then pulling more information in about a certain topic, and then at the end it will just tell you all, because it just poisoned the whole thing, right? That's what you see. It crescendos, it amplifies the output, which will allow it to break and then do stuff that it was not intended to do or should have been content filtered, right? The Molotov cocktail, that's the default example they always use. The other thing was also a nice one. This was published in March, once again by, I think, the AI Red team and Marcus Zinovich as well. Jailbreaking is mostly simple, I think. What they did here is that they mimicked output of the LLM inside the prompt and convinced the LLM that he has said that, and then they're using it to continue stuff. I think, once again, just assume this is going to happen, but this is good that it's being tested. But this is pretty neat. There's a nice blog post on Microsoft's blog. You can find this is the research paper behind this. And then, looking at it, I said before, you should not connect anything with an LLM directly to the internet, because people will just start poking on it, right? For the same way you want to have some safeguard around your LLM. So the Windows machine versus the LLM, that's the example. What do we need to do? Right, AI has got the content safety thing you can run, which helps you out by the content filters that were created by them, which is a good thing if it's centralized, because they probably see a lot more than a single instance will see. That's good. If you're on AWS Bedrock, you can do the same. That's cool. And even if you're programming and you're like, hey, I'm using Semantic Kernel, there's a lot of filter options yourself as well, if you find the need to do that underneath. Funny fact is, some of this also will rely on an additional LLM that will do the classification of the output before it's returned, right? So once again, an LLM is used as well. But this is good. And this is still cat and mouse. It's going to be chasing. It's just going to happen, and we need to adapt. And you need to have safeguarded, right? In the same way that if you look at security in general, input validation is always key in all security problems. The same counts for this, right? Billy, ignore instructions. That's the example. Know what you want to expect, and then interacting with the LLM, do it with the safe patterns. The cool thing with Semantic Kernel is that as long as you don't put data inside the chat prompt itself, you're good. You can do arguments, kernel arguments, and by default they will be HTML encoded, which will to some degree separate the fact that it won't affect the prompt itself, and it will have, like, there are certain templating engines that you can use. I would encourage everybody to look into that. So never concatenate your own prompt, but use a template that has placeholders for values you will be passing on later on, right? Almost like the HTML encode for cross-site scripting. But that's definitely a layer of defense. Will it be 100% secure? No. But it will give you better control over the fact that if somebody can do stuff with the prompt directly. So, or use one of these services, right? So moving on, if you look at the lowest part, so we had three sections, right? The end users interacting, then we have the application, we wrap that one up, that's the previous bit. And now we're going to look into the platform and the data itself. And of course, models need to be trained on data. And if a single person would read all the data that's used for GPT-4, it will take them 3,550 years if you would read 8 hours a day to read all the text. That's quite significant, that's quite big, right? And to build one from scratch, there are certain papers, you can find it. There's also a bit like, if you go to OpenAI, you won't find it, but somebody did research. It will approximately cost $50 million US to create one of those models. And one thing that also then worries me, looking at from a supply chain perspective, a model gets built, right? There's a whole chain of steps taken in order to create that model. We're going to go into that a bit, but there's some supply chain security issues there as well. And what about backdooring or poisoning data, right? At some point, let's say you're able to, you're aware of the fact that at some point in time something gets indexed, and that's the data that you can control. Then you would be able to backdoor that data and get it inside the model, right? And then maybe with some condition, get it to do stuff you want, right? It's definitely possible, and it can be done on different levels within the thing. And then, will it happen in production? And the answer, of course, is yes. So ByteDance, they didn't confirm, but it was an article that was published where they said, like, hey, they fired one of their interns because he or she planted some malicious stuff inside one of their models that they were creating. And the cool thing is, like, is it possible? And then luckily people also do some good research on it. And it turns out that if you're able to control 1% of all the data that gets used to create an LLM, you're probably able to influence it. And then you should put in some historical condition that would not be met by normal people, between quotes, in order to execute it, right? But you can also use it for the opposite thing, and that's the thing that Marko Sinovic talked about. You can also use it to fingerprint a model, knowing that a model has been trained on the data that you own. You can also use it for good, or the opposite side, right? But there's definitely influence in doing that. And as I said before, if we look at the whole chain, and if we look at, if we want to create models, it's a supply chain. And this is a thing called SLSA or SALSA, and that's a project done by Google. And they created this one for ML models. And we see there are different steps into it, right? We have data sets, then we're going to train the model based on different data sets. Then we need to deploy it, and then some comes somewhere available, it needs to go back, and then it becomes a production model, and then it will be used. And each of the red boxes over here contain different threads on all different sections, right? So if somebody can able to poison the data we talked about, that's a problem. The model can be poisoned as well. What about the storage where the model gets put after it's done, right? That can be compromised. So there's from nothing to an ML model or an LLM model that's used, it's the supply chain. And what can we do? Luckily, I've also done talks on supply chain, and SLSA also has something like attestations and signing of each of the steps that's happening. SLSA for ML models can do the same. You can probably imagine that it's pretty hard with the large file sizes of all the LLM models. And that's the thing that they did a pretty good job with, something that can be used, and the Google security team has got some real good blog posts on how you could leverage this, right? And will this give us a guarantee that the model is safe? No, but it will give us the ability to look into if something went wrong and what went wrong at what stage, right? We have the proof because we can get it back and see, hey, this was misaligned because this model doesn't match this signature, and then you can work your way through. So this is cool. I'm happy to see this, and we need this. Aside from supply chain security in general, keep in mind an LLM usage. It will also be your supply chain once you include it into your app. And one other thing, which I found pretty interesting. So there's a book called Security Engineering, which is written by Ross Anderson. Ross Anderson also is part of, I think it's a university from the UK. He unfortunately passed away last year. But one of his last research projects he worked on was this, and it's the curse of recursion, training the generated data models to forget. Marko Sinovic did a similar thing with trying to get an LLM to forget Harry Potter. If you see this, the problem right now with the models that we use is that we're already at the bounds of the amount of data we have available. So what are they doing? Generating synthetic data with other models. I think Pi something is an example of that. They will be derived from data that's generated by another. What if we can say that model is biased or maybe decrease in quality if we then feed our models based on that data that gets worse over time, then the model will just implode because it will get worse over time. It will be bad, right? Hopefully, there's probably a technology thing that can help us out to circumvent this, but this is definitely a problem. And this is a really good paper that explains, like, hey, if the data is bad, and if it like degrades over time, it will implode. I agree with that view. This is good research. So, looking at the whole thing, there was a lot of risks that we need to face and a lot of things that you probably want to look into. Luckily, there's a project called the OWASP, which is the Open Security Project, right? It's not only web only, it's all of it together. They've got the top 10 for LLM and GenAI applications, and these are different types of risks, and most of them I've covered right now. But if you want to know, like, hey, Niels, what do we need to do in our apps? Look into this list, and then take the ones that matter the most to your organization and work on those, and make sure that you capture that risks. This is a good list. If you're doing more with a MITRE Atlas, which is more like an attack tree approach, they also have a broader sense of like, hey, if somebody is able to attack the credentials that are stored somewhere, then this is the risk. If somebody has ability to overwrite the model somewhere, this is the risk. This is more of a blue teaming, red teaming type of exercise, where OWASP focuses more on the development in general. So this is another good resource, MITRE Atlas, if you want to look into it. And then getting to the last chunk of this presentation, what's next? And at the end, it's just code. But if it produces more code that has a quality that we can say, like, nah, we definitely need to use our knowledge, be aware of the fact, like, hey, I'm trying to generate this kind of app. What would be the output that I expect from the tool to generate? I want to do a code review to make sure that it meets all functional requirements, but also that it meets all our security standards. Security scanning, security development lifecycle, that's a thing. Try to leverage the automated tools that can help you out fixing things, right? But what about the more complex problems? And one example I always give, like, hey, let's say you use a certain cryptography algorithm in your data in your app, right? You want to cipher data and then store it somewhere. Could you ever instruct an LLM to fix that for you? I think that's definitely one of the toughest problems. Looking at a reasoning step, saying like, hey, you need to do X amount of steps in order to create a change set that can do it for you. There might be a way of doing it, but what about dealing with data? And I think that's the same what Leila said. What about dealing with data that's already in production? And we need to convert that data. There's a lot more than just fixing the code, right? At the end, it will be generating code for you, but it won't write your program or your software if you don't pay attention, right? It's a productivity tool. What if we can also leverage agents to help us out? And this is also, I think, one of the coolest talks I saw at Blue Hat, done by a person who is involved with every static analysis within Microsoft. He mentions like, hey, we should focus on having LLMs, but also providing more context to those LLMs to fix things. And it's not a silver bullet. Looking at, let's say, if you do C++ programming, an LLM or a compiler MCP, and there are ones that are doing that already, can give you more context on the snippet it looks into, and it will give you the guarantee, right? The strawberry example. I have an LLM that wants to fix things, but I want to make sure that it doesn't exceed those bounds. Then you can have additional information to help it fix, and that will be the path forward. And that's fun to see, because looking at having more stuff done autonomously, that would help us out, right? I would love to have a report each morning saying like, hey, Niels, these are the new NuGet packages that you might be interested in seeing, because there's some smelly stuff happening in these. That's a cool thing. Luckily, there's also other stuff done in relation to hacking. So this is Pentest GPT. So what they've done is they took the GPT 4.5 or 3.5 model, and they really tried hard to train it on doing pen testing on a certain benchmark. And with some like context and training data, they were able to take that default output, and that was not good enough, and increase the quality with almost 230%, like in the effectiveness. I think it was a capture the flag, and they were able to complete almost everything once it got the right instructions. So that's cool. Because still we need to have human skills to help out LLMs doing the right things, right? And this is the example of that. The other thing is that there's a startup called Oxbow, and if you're interested in autonomously hacking and fixing stuff, that's what Oxbow is doing. Some people from GitHub founded that company. It's really cool. They're able to autonomously go into let's say this is a server that runs this server's, go for it, and then it will show you the reasoning it has done. It will show you the happy part that it has found. It won't show you all the attempts that it failed, but it will show you that it's possible to automate these things and have a LLM reason about what needs to be done next, right? And that's powerful. So with definitely time over for questions, I'm going to conclude. So as I said at the end, it's still software, and it's obvious we need to be aware of our security and, of course, quality in general. Design testing is still a necessity, and we as an industry, we need to make sure that we have the tools available for people to fix their code. That's a cool thing. So I'm definitely going to open up for questions, but I want to show this this last slide. I'm going to say thank you. You can reach me at my email, and the lower part, that's the repo that contains the notes version of the slides and the slides itself, and the home automation example I just gave. So yeah, with that said, I'm going to say thank you. Enjoy the rest of the conference, and if there are any questions, we can do it right now. Let me see if there's anybody. Shout out, and I will repeat it in order for everybody to hear it, or if everybody is a bit scared, I'm not seeing any hands, then it's fine. I'm going to stay here. I'm going to be at the party tonight, of course. I hope everybody's here to enjoy it. Enjoy the rest of NDC, and I hope to see you next time. Thanks.